All right, great. Let's get started. Welcome everyone to the CDR and Databricks Lunch and Learn. On the screen, you will see two links that I will be posting here in the chat shortly. You can navigate to them to learn more about upcoming training dates and topics or view previous training resources. Before we get started, let's go over some administrative announcements. This call is being recorded. And please stay muted to minimize interruptions. Since today's call is only 30 minutes, the Q&A section there won't be one at the end. So we will be using the Zoom survey. If you have any questions, you can ask them in that survey itself. And lastly, all meeting materials will be made available in the CCSQ DNA portal. Just make sure to give us a few days to turn those around. With that said, I'm going to go ahead and stop screen sharing and hand it over to our speaker for today, and that's Oren.
Excellent. Thank you. Okay, hopefully you can all see my screen.
Yes, we can see it.
Excellent. So let's get started. Good afternoon. I'm going to be speaking today about working code versus good code. And the trick behind working code versus good code is that when you write code, when you're writing code, it all looks good because you're thinking about it, you're familiar with what's happening, you know what you want to do, and you've been going over it. If you've been working on it for a month, you've been spending a lot of hours on it. And at the time you create it, it usually looks good. You understand it, you know what you did, it's great. Problem is, 6 months later, you might come back to your code, or maybe you're going to have to inherit somebody else's code. Somebody might be away for a week and you have to run their stuff, or maybe they'll go to another position and you have to inherit their code. And that's when you run into a lot of problems because 6 months later, you may have forgotten some of the stuff you did, you may have forgotten why you did one thing instead of another thing. And that's where having just working code versus good code comes back to be a problem for you. Because at that point, that's when you're running into issues. And so to help people that do this, we're going to talk about working code versus good code. We're going to talk about some guidelines, some things to avoid, some guidelines that you can follow to make sure your code can be easily understood. Because remember, to somebody else, your code is written by other people. And you want to make sure that your stuff is easily understood by others, just like other people should. You'd hope that other people write stuff nicely so that way you can understand their stuff. So the way I think of code is I sort of think it should be like an essay. So especially when you're working in Databricks. So in Databricks, we have notebook cells. And I like to think of those as like a sentence. And the idea is if I have a sentence that's like 300 words long, I'll be able to read it if I spend enough time on it. It'll take me a few extra minutes. But if you put it into an essay, even if it's a great sentence, it's still a sentence that long is still problematic. Ideally, you would get your sentences into something smaller. Notebook cells should be the same way. If you have a command that's a few hundred lines long, it's going to be hard for others to understand. You probably maybe not haven't thought through what can be in each spot. And basically, it's like reading a sentence that doesn't have a period. You might be saying the same thing as you would with another 4 or 5 sentences, but just parsing it better so that notebook cell only gets a sentence, only has a specific point, and only does so much is going to make it easier for you. It's easier for others when they come back to it. Because I know that when I see a notebook cell, it's 200 lines, it makes me freeze up for a second. Notebooks, you should think of as paragraphs. You have a paragraph, and when you write your paragraph, your first sentence is your topic sentence, and your paragraph probably isn't going to be a 10-page long thing. You want to have the same philosophy for a notebook. You want your notebook to solve a specific limited problem. You don't necessarily need to use one notebook to solve things. You can use many, but you want to have a limited scope. You want to have a limited problem. You want to be somewhat standalone, but you want to be able to cover a step. And that way, if it covers a step, it only has a limited thing. And if you're working on a whole major project and you can split it from one notebook to 10 notebooks, when something goes wrong, it's going to be a lot easier to troubleshoot. So you want to think of notebooks as a paragraph and less as a total essay. So when you're writing an essay, you're typically going to quote from a source. And maybe you want to support an assertion that you have in there. So you might quote from a history book. You're not going to quote a 4-page excerpt from a history book. That would just be crazy for an essay, depending on how long it's going to be. But if you can quote from a source, then that, and you put in a footnote showing where you got it, then that can give your essay some authority and it can help you help you avoid devoting excess time to explaining background that may or may not be directly relevant. And for programs, you want to do something similar. Namely, you want to have a code base. And basically, the idea behind a code base is you have classes, you have functions inside there that your team has created, and you can quote from that code base, and you can use the credibility of that code base to help people understand what's going on in your code. And one of the good reasons for this is because a function that you create on your own, nobody else is familiar with. But if you have a code base and you have code that is in that code base that's been, reviewed by a few people on your team and it's been looked at, then when somebody else sees you using a function from there, they're going to know it's fine code. They know they don't have anything to worry about how you're using the code because the function's been approved, the function's being maintained, and you can be relatively sure that if it's in the code base and it's in production, it's going to be fine to use. So we've talked about how notebooks should be considered to be like paragraphs. And what we have jobs that can be used to create really what's an essay. And really the idea behind the job is you create a job or a workflow, and basically you link a bunch of notebooks together. And depending on how you're doing things, you can structure the notebooks in that job so they run in parallel or in a defined order to ensure that things run efficiently. And that can actually save you a lot of real time compared to just having everything in one notebook. For example, suppose you have a case where you're doing some analytics, you have some membership data that you're interested in, you have some claim data information you're interested in, you have some provider data you're interested in. And I mean, you could run them one after the other, but what you can also do is you can run them all in 3 separate notebooks, have them run in parallel, and then essentially they're running at the same time. And that comes into handy because your provider stuff might not take so long, but grabbing beneficiary data takes a while, grabbing claims data can take a while. And if you can do them in separate notebooks, they're all running at the same time. And therefore you don't have to wait for them. And that especially comes in handy if like you're looking at claims data for a bunch of different years, right? So instead of having each of them in one single notebook, you could have 5 different notebooks grabbing data from 5 different years. They're all running at the same time. And then you have all your 5 files. And then you can create another notebook that waits until those 5 files are created and does something to merge them. And it'll save a lot of time and also make things easier to understand because now you have your stuff, you have your workflow that has its entire goal, and your notebook is only doing one small thing as opposed to doing everything. So it's going to be smaller and it's going to be easier to understand what the goal of the notebook is. And then finally, there is comment usage. In general, the best practice for comments is to explain why code what it does and not explain what it's doing. So you want it to explain, maybe you're working on something and you're not sure what the coefficient is, so you might include an email from Bob saying that the coefficient needs to be 1.7. I know I've worked at places where we need to explain why we're using certain keys to do the merge. And sometimes we were working with really weird data sets that had fields, but the fields weren't well defined. And the fields they didn't actually grab all the data. They did it in a weird way. It wasn't meant to be used on those fields. So having comments explaining why we're using such and such fields to do a join, or why we're not including such and such fields could come into handy. For the stuff that we do for our presentations, we usually do use comments to explain what it's doing. And that's primarily because these notebooks are meant to teach rather than actually run a process. But if you're doing something to run a process, then trying to focus on the why as opposed to what is usually a good strategy. All right, so let's talk about some problems with inefficient code. So this is an example of spaghetti code I got from ChatGPT. And this function, this function is a bit of a mess, basically. You can look at it. It is pretty long. It's about 40 lines. And the problem is it just does a lot of things because you can see it's looking to see what the status is. You can see looking for payment status. You can see if the items are there, it does something. And if you got a function like this, it would take you a while to figure out what's happening. And because it's so convoluted, it would take you a while to just like parse everything out. And so you might not want to do something like that when you're actually running it. You might want to find ways to make this not spaghetti code. So you want to make a function that does fewer things. Or maybe if you have to, you want to make many smaller functions and call them all in a main functions. That way you don't have one big thing doing this whole big thing. But in general, code like this, it makes sense at the time when you're creating it. But if you come back to it 30 months later, it's going to take you a minute to understand what's happening here. And so this is an example of code that it'll work. It's just not good code. So another problem is when you have long rambling commands. What this code is doing is it is doing a whole bunch of things. It's adding a whole bunch of columns to what's going on. And the problem is I have 140 lines of it. And this is what happens when you run it. This is what it looks like. And the output doesn't make any sense. You're not gonna be able to figure anything out. And reading the code, it's just gonna take a while because you're adding 25 things here. The name of the data frames don't change. So it's hard to understand what exactly is going on. And you get code like this, you're gonna get an error somewhere in this cell, and it might tell you where, but you still really need to read the whole cell to figure what's going on. And if somebody sees an error in here, it's just gonna take them a while to figure out what's happening, and it's gonna make things really complicated for them. And if you could break it up into something smaller, and maybe only add certain things, then you're gonna find it's gonna be a lot easier to troubleshoot if something bad happens. The second problem is clarity. And when you're writing code, you can name things anything you want. You can call columns anything you want. And at the time you're writing it, it'll probably even make sense to you because you'll know if you call a data frame df, you'll know what it's doing because you've been breaking on this code for 2 or 3 weeks, and you understand what was happening, and it's great. Or maybe you'll remember a column. If you call it X, you'll remember what it's doing because you've been working on it for a while. 6 months later, and you come back to it and you've been working it for a while, it's going to be harder to do that. So you want to make sure to properly name parameters. So that way it's easier to understand what they're doing in the future. And also you want to try and use a single type of case for parameters. You want to either use snake case or camel case. And basically the idea is you want to try and make sure you're not guessing whether to use capital letters or all lowercase or underscores or what. We work a lot with Databricks log data, and every once in a while, depending on what they're doing, they change the things. So sometimes they might use capital, sometimes they might want to use all lowercase. And it's always difficult to try and remember whether parameter ID is there's an underscore, or whether there is an uppercase, or whether it's all lowercase. So if you use one thing, then or one standard, and it doesn't really matter what it is, as long as it's used consistently, then you won't have to guess. You'll know how your parameters are named. And when you're fixing things, you won't need to look to try and figure out how you called things before. Um, in general, it's best to use data frames that actually describe the data rather than using generic names like DF or data frame. Using DF is very common. If you come back to code in 6 months, you'll see a DF and it will mean nothing to you because DF itself doesn't mean anything. But if you call it by something that's a bit clearer, then you may understand what's going on. It'll help you read it. And finally, when filtering a data frame, you want to try and rename it to show how it's been changed. We're going to give an example of that soon coming up. So here, this is an example of poorly named parameters. Here we have a lot of names, and the names themselves mean nothing. And it's not clear why we're doing this stuff. Like, why are we multiplying the age by 2? What gain are we getting from that? Or why did we decide that a high fare is greater than 50? And so if you have poorly named parameters, you won't understand what they're doing, and you'll need to go through all your code to try and figure out what's happening. And now here's a case where we have poorly named parameters, and you can see this is a lot easier. You can see here we're describing what this is at least. And so ideally you have a comment saying why was over 50, but at least you understand what this field is. Fair 50 USD makes sense. X1 does not. Family size makes sense. SIB or whatever it was called also does not. You use good columns and you'll be able to understand them when you come back to it. Also, data frames. Here we have X by C123, absolutely meaningless. You go down here, we have survivor summary by class and gender. And there you just need to read that and you'll understand what the goal of the data frame is. And you can see how this comes in there. You can see how we're getting the survivor. You can see the age fair. You can understand why we're doing things. And then you can understand the code. Also, data frame names changed properly. And here you just have DF and all these, hard to explain what's going on. Here we have raw data, we have filtered, we have result, and you can see what's going on in each of the steps. And that's going to help you a lot because that way you'll know what's going on, why you changed it, and how the data frame has progressed. When you do that, you do need to consider resource considerations. If you have a really large data frame, maybe you don't want to do that. And if you have a medium-sized one, you may need to do caches. Problem 3, you want to make sure not to use 3 steps to do what you can in 1 step. You use 3 steps, you're going to have a lot of clutter and you're going to have a lot of code. And if you just do it in 1 step, it'll be a lot easier to understand. And here is an example of that. Instead of doing these 3 right here, we just do everything in 1 code snippet. And now I can easily understand what's happening. Issue number 4, optimization. You want to make sure that when you're grabbing data, you want to grab as little data as possible. So you want to make sure if you have a huge file, like if you're working membership data and you're interested in 2024 beneficiary data, you don't want to grab just all the 2024 data set because that's huge. You just want to grab the stuff that you're interested in. So maybe if you're looking at Indiana, for example, you want to make sure that you want to do the filters as soon as possible. So that way you grab as little data as possible. So that way your stuff runs faster. You also want to cache data frames that are used frequently, and you want to use broadcast joins. And this is an example when we are just grabbing a data set and we're just going to do a count on everything. And this is a relatively small data set, only 393,000 records. So it took 0.76 seconds. But if you go down below here, we are doing the filter right away. We're only grabbing 125,000 data records, and it took 0.46 seconds. So it definitely went a lot quicker. So you want to make sure not to grab everything, but rather you want to filter so you grab as little as possible. Next up is doing a cache, and caches are used to store a data frame in memory. And you need to be careful. You can't do anything that is too huge because you are storing it in memory and there's a limited amount of memory. But if you have like a decent sized file and it's going to be used a lot, but it's not huge, like we're talking, I don't know, hundreds of gigabytes maybe, then you want to cache it in memory, and that way it's going to be quicker to process. And what you need to understand is you can't just do a cache by itself. You need to run something like a count after doing the cache. So this is an example of doing a cache. Here we are grabbing a Titanic training data set. We are doing a filter on it. We're only grabbing where the P class is 1. So those are the richest people. And then we're doing a cache and then we're doing a count. And then if I'm going to use this file in 15 places, it is in memory. So it's going to be a lot quicker to, it's going to be a lot easier and quicker to process it and do things with it. Another thing that you should be familiar with are broadcast joins. Broadcast joins are typically done automatically by Spark. So you don't need to worry about it so much. They are going to do automatically if it thinks you'll make things faster. But basically the idea is it's going to save data into, it's going to send a lookup table into each worker node. And then it's going to do a join on each worker node as opposed to doing it one at a time. And broadcast join stuff, the lookup table, it's usually used when you have a lookup table and you want to join it to a large table. So suppose I have beneficiary data and I want to get state name instead of state code. So I have a lookup table, it has state code, state names. I want to join it to a huge table. It's a relatively small table that I'm using to join on because I mean, it's got 50 records in it. But what it's going to do is it's going to take that small table, it's going to move it to each worker node, and then it's going to do the join on each worker node. And it is going to go much faster than just doing it one by one. And you can configure this by using the start equal auto broadcast join threshold. You can change that if you have something that's like just over the threshold and you think it'll be better. But that's going to be something that can make things more efficient. And here is an example of that. Here we have a lookup table with 30 things in it. And then we are joining that to whatever is in our Titanic training data set. And since it's going to each node, it's going to go faster than if we just did nothing at all, if we just did a normal join. The final thing we're going to touch on is code reuse. So we want to try to avoid reusing code in multiple places. And doing this requires, if we do this, then if you use code in multiple places, then what's going to happen is you make a change to one snippet, you have to make changes to hundreds of places. If you just use one function, you just change the function and it goes everywhere automatically. And also it makes it more difficult to build enhancements for code snippets that you do the same thing. So suppose I have something that I'm working on maybe something that does a join, or maybe it does a merge, and maybe I want to throw some checks into it. So if I do it in a function that is going to be called, it's relatively easy to do it once. If I have the stuff in hundreds of places, then I need to make the enhancements in hundreds of places. It gets a lot harder. And so that's why what you want to try and do is you want to try and build a code base in one area and then call them into your notebooks. And this is an example of something we're doing here. We've got a function that can do it. It grabs the full name, does first name, last name, something that you might want to do in a lot of different places. But if I ever wanted to make a change to it, then I would just make it in one place. And for an example of an enhanced function, we have our ls safe. If you do an ls on an invalid file path, it will cause an error, which will break your notebook. Here, this is something that we created. This is a ls safe. And basically what it does is it checks to make sure it's a valid path. And if it's not a valid path, it is going to, instead of doing a display, it's going to print that there are no contents found. And that way you don't get an error. And that way your notebooks continue running even if the ls fails. And so that's an example of an enhanced function and an example of something you might want to do to make things work better. And yep, so in conclusion, other people's code, even our own, it can be difficult to understand if we see it for the first time, or if we come back to it after a long break. But if we work on things to make our code good instead of working, then that'll make that problems and the trouble less likely to happen. All right, thank you for coming and listening to me today. We're
Thank you,
back to you.
Oren. Awesome. Thanks, Oren. And for those who joined a little later, I'm gonna paste the notebook link here in the chat once more. And before everyone drops, if you all don't mind taking our survey and letting us know how we did today, how we can improve, and if there were questions for Oren that you didn't get the chance to ask him today, you are more than welcome to ask him here in this Zoom poll at the very end. And keep an eye out for our Lunch and Learn next week. We have that happening next week at 12 p.m. Eastern time. So make sure you can join. And yeah, thank you all for joining today.